Voltage and current at our terminals for this network, VT and IT, we're asked what is the average power at our elements terminals? Well, to find the average power, what we're going to do is we're going to have P is equal to, and then we know P is equal to voltage times current, right? That's if we just had something like these two. But now for the rest of these, we have a sine or cosine. So what we're going to need to do is actually rewrite this so that it's all in terms of cosine. So our VT is going to be equal to, we're going to have an 80 here plus a 200, and we're going to have cosine. And then in our cosine, we only care about the angle here, okay? We don't need the omega. So we're going to have 45 degrees plus 60. We need to convert this sine to cosine. So cosine is 90 degrees behind sine. So this is going to be minus 90 degrees. And then for I of t, it's going to be equal to 10. We're going to have plus 6 cosine, remember minus 90 degrees, so we're going to have minus 15 degrees. And then we're going to have plus 3 cosine of negative 30 degrees. So this is our current equation. Now, it's asking us what is the average power at elements terminals. So we're going to have to use the formula right here, the average power consumed by impedance, right? So we have this as our average power. We're going to need to find it. In our P, it's going to be equal to, we have, let's see, what was it? It was the I max times V max. So we're going to have I times V divided by 2 cosine of our theta I minus the theta V inside of here, right? Okay, so to find the power, it's going to be equal to our first part. We just have an 80 times 10 here. So remember how I said if it looks something like how I circled earlier, it's just going to be the voltage times current because we don't have any cosine sign. So all we are going to have here, if we have something that looks like this, is 80 times 10. And then we're going to have plus, we're going to follow the formula, and we have 200 times 6. I kind of switched these around, but that's okay. Divided by 2 cosine. And then we have a negative 15 minus 45 degrees. And then we will have plus, we are going to have the 3 times 60 divided by 2, and then cosine the angle of I minus angle of V. And again, this formula just comes from notes that you can even Google this formula. And that's exactly what I did to find the average power right there. So if you do that, you're going to get this. And now we can look at the angles inside the cosine. So we're going to have cosine of negative 60. And this is going to give us 1/2. And then this, I didn't write the angles in here, but we're going to have negative 30 degrees minus a negative 90 degrees. So this is going to give us the cosine of 60. And this is also going to be 1/2. So what we can do is we can take our P and set it equal to the 80 times 10, which is 800, plus the 200 times 6 divided by 2 divided by 2. And if we have these two 2's, they combine to make a 4, and so we could turn this into a 50, and that's going to give us a 300. And then we could do the same thing here, combine these and do a 4. This will become a 15. So we'll have 3 times 15, which is 45. So we have 800 plus 300, which is 1,100, and then we're going to have 1,100 plus the 45, so we have 1145. So the answer for a P is 1145, and that lines up for this equation that we have right here. Next, we're going to look at part B, which is finding the RMS value of our voltage. Now, if we look at this right here, we're going to be dealing with RMS now. So we need these VRMS. What I'm going to do is just take a screenshot of it. This is the equation, and then we can come back to what we have right here. Our VRMS is equal to the square root. So we're not explicitly given like our AVs and our ANs and stuff, but our AV is going to be what we have out here. We're going to have the 80 just squared plus the summation of the rest of the stuff. And our A of n is basically going to be these values. So this value and this value, and they get plugged in here. So we are going to have our plus, and then we have 200 over the square root of 2. This is all squared, plus, then we'll have our 60 over the square root of 2 and this is all squared. And this is going to give us approximately 168. So our answer for our VRMS is 168 VRMS. Now, there's nothing for IRMS in the notes. And that's because IRMS and VRMS are interchangeable. So if we use the VRMS, we're going to find our IRMS the same exact way. We're just going to replace the VRMS and the IRMS. So for the IRMS, we're just going to write it over here. We're going to set it equal to the square root of our 10 squared plus, and I write it like this. If we have a squared on the outside, like how we have right here and right here, well, we can just square the bottom and it's just going to be divided by 2. So we're basically going to have our 6 squared, which is going to give us 36 divided by 2. And I'll write this out just in case we're looking at it later. So we'll have 6 over the square root of 2 squared. But like I was saying, what I like to do is I like to just look at it. We have 36 up top, we'll have 2 on the bottom. And so 36 divided by 2 is just going to give us 18. And it's just a little bit cleaner to write out. But it is easier to see the process this way. So we're going to have a plus 3 over the square root of 2. And this is all going to be squared. And this is going to give us approximately 11 ARMS for our problem. And that is all of the homework for network analysis. We've finished it all. We've done everything. We've gone through tons of problems related to the notes that are linked below the like button in the description. We've gone over so many different sections, from chapter 9 to chapter 10 to chapter 12 to 13, 14, 15, and 16. We've covered so much material. So going over all of this and now doing examples has been really extensive, but I feel like we've covered the material really, really well. And also the quizzes and practice exams are in video form, and there's also some stuff in the notes. And that is all for network analysis.